There's a mysterious interstellar object hurtling towards our solar system, exciting scientists across the globe.
3i Atlas is moving closer to the sun. There's still so much we don't know, and with
the James Webb Space Telescope has just confirmed something that has shaken the astronomical community to its core. The interstellar object 3i Atlas, already a mysterious traveler from beyond our solar system, has been observed with unprecedented clarity by Webb's instruments, and its trajectory has been pinned down with unsettling certainty. It is not merely passing through the solar system as once thought. The updated data show that it is on a collision course with Mars, a revelation that turns a rare astronomical curiosity into a monumental cosmic event. Before we start, smash the like and subscribe buttons for more updates. The telescope's ability to pierce the cold depths of space with its infrared eyes has given scientists the precision they needed to track 3i Atlas across the dark backdrop of interstellar space. What appeared to be just another passing visitor from the void has instead become a body of immense importance. Its orbit is narrowing, and the gravitational pull of the sun has guided it into a path that intersects with Mars. Unlike earlier speculations where margins of error left room for doubt, Webb's observations leave almost no ambiguity. The numbers, trajectories, and models all converge on one conclusion: impact. For planetary scientists, this is both terrifying and exhilarating. Mars, often considered Earth's sibling in terms of planetary exploration, has been the focus of countless robotic missions. Its surface, scarred by ancient craters, already tells a story of countless collisions across billions of years. But this would not be an ancient scar frozen in time. It would be an unfolding event, an interstellar object colliding with a planet we are actively studying. No human or machine has ever been alive to witness such a thing. The very nature of 3i Atlas adds to the significance. This is not a fragment from the asteroid belt, not a stray comet looping back after thousands of years, but a visitor from beyond the solar system itself. Like Oumuamua before it, and the comet Borisov after that, it is an emissary from elsewhere in the galaxy. Its composition may carry materials forged in other stellar nurseries, dusted by the explosions of other stars, and shaped by environments no probe from Earth has ever visited. To collide with Mars means that some of this alien matter will be delivered directly to a planet whose mysteries already captivate scientists searching for signs of past life. The scale of the collision is something Webb's data has made it possible to estimate with sobering accuracy. 3i Atlas is large enough that the energy released upon impact would dwarf even the most cataclysmic natural events Mars has experienced in recorded human observation. The kinetic force would gouge out a fresh crater visible from orbit, lofting debris miles into the thin Martian atmosphere. The dust could hang suspended for months, perhaps years, altering the climate of the planet in ways our rovers and orbiters will be in perfect position to record. Unlike the Earth, where atmosphere and tectonics erase scars over geological timescales, Mars preserves them almost indefinitely. The crater left by 3i Atlas will not just be a fresh wound, but a permanent monument to this interstellar encounter. The scientific opportunities are staggering. Every space agency with instruments in orbit around Mars or rovers on its surface now faces the chance to watch a cosmic collision in real time. Imagine the panoramic cameras on the rovers catching the fiery descent of a body that has traveled for millions, maybe billions of years through interstellar space. Imagine orbiters mapping the explosion and then returning to chart the aftermath, from the spread of ejecta to the way Martian winds move the dust across the landscape. Each image, each data point, would enrich our understanding of impact dynamics, planetary geology, and interstellar chemistry. Beyond science, there is the drama of cosmic perspective. Humanity has always looked at Mars as the next frontier, the world where explorers may one day step. To know that such a planet, so close, so tangible in our imagination, is about to experience a direct strike from beyond the solar system forces us to confront the scale and unpredictability of the universe. The cosmos is not a quiet backdrop for human ambition. It is alive with movement, collisions, and chance encounters that remind us of our fragility and our fortune. For planetary defense experts, the Webb confirmation underscores the importance of vigilance. Although Mars is the target this time, the very fact that interstellar objects can be drawn into collision courses with planets shows how dynamic and unpredictable these visitors can be. The calculations reveal how tiny gravitational nudges from the Sun or from planetary flybys can alter paths dramatically. If 3I Atlas had been shifted just slightly differently, Earth could just as easily have been in its path. That sobering truth fuels discussions about detection, tracking, and perhaps one-day deflection of cosmic intruders. Mars itself, however, becomes a kind of test case. The impact will serve as a natural laboratory to study what happens when a high-velocity interstellar object slams into a terrestrial planet. Researchers will be able to test computer models against reality, refine their simulations, and better predict what would occur if Earth were ever in the same situation. The debris cloud, the thermal pulse, the seismic waves, all will be measured, compared, and analyzed. Mars is, in effect, becoming a proving ground for understanding cosmic impacts at an unprecedented scale. The timing of the Webb confirmation also heightens the sense of immediacy. Missions already orbiting Mars, such as MAVEN, Mars Odyssey, the European Space Agency's Trace Gas Orbiter, and others, are equipped to gather data from the event. Rovers like Perseverance and Curiosity, still active on the surface, could potentially document the sky as 3I Atlas makes its final approach. Even if not directly under the impact trajectory, they could record atmospheric changes, seismic vibrations, and the settling of fine dust over their solar panels and cameras. Every instrument already on or around the planet becomes part of a coordinated observational network, ready to turn an astronomical event into a scientific goldmine. There is also the haunting thought of what lies inside 3I Atlas. The chemistry of its ices, rocks, and dust could differ radically from anything in the solar system. The shock of impact will vaporize much of it, but some fraction will be embedded in Martian soil and rock, creating a unique mixing of Martian and interstellar matter. Future missions could one day land in the crater to collect samples, bringing back pieces of another star system that have been fused into the Martian surface. That prospect alone could redefine planetary science and astrobiology. Even more striking is the symbolism of Mars itself as the site of the collision. Humanity has not yet set foot on its surface, yet we are already imagining bases, habitats, and colonies there. The Webb discovery underscores how vulnerable such endeavors would be. Mars is not exempt from the randomness of cosmic impacts. If a future settlement were already in place, this event would have been catastrophic for it. In that sense, 3I Atlas becomes a reminder not only of scientific opportunity, but also of the risks that await humans as they expand outward. The media attention surrounding this confirmation has been enormous, but at its heart, the story is about our relationship to the cosmos. The James Webb Space Telescope, a triumph of human engineering, has given us the vision to see farther and with more precision than ever before. That vision has revealed not just distant galaxies, but a clear and present event unfolding in our own celestial neighborhood. The story of 3I Atlas and Mars is a story of how observation transforms wonder into understanding, and how understanding confronts us with both awe and humility. Astronomers are now working feverishly to refine every parameter of the impact. The angle of entry, the velocity at collision, the precise latitude and longitude on Mars, all are being modeled with the freshest Webb data. Each refinement not only gives clearer predictions, but also sharpens the expectations for what instruments should look for. Scientists anticipate shock waves radiating through the Martian crust, and orbiters will be poised to detect subtle changes in the planet's exosphere. The full choreography of the collision is being mapped out in advance so that when it happens, nothing is missed. Meanwhile, public fascination is rising. Unlike distant cosmic phenomena that unfold light years away, this will happen on a planet that humans can photograph with backyard telescopes. Amateur astronomers will point their equipment toward Mars, hoping to catch the brilliant flash of the impact. News outlets will follow each step, from final approach to aftermath, and the world will watch together as Mars gains a new scar. It is rare for cosmic events to bridge the gap between the scientific community and the broader public, but this one does. It is both technically profound and viscerally dramatic. The collision of 3I Atlas with Mars is not just about a trajectory intersecting with a planet, it is about the way the universe refuses to remain static. It is about motion, energy, and transformation. Mars, long studied as a fossil world frozen in time, is about to be struck by something utterly alien. The red planet will change, not subtly but visibly, and human eyes, guided by robotic instruments and telescopes, will witness it as it happens. That reality alone ensures that the confirmation by James Webb will stand as one of the defining discoveries of this era of astronomy. And so, as the countdown continues, the atmosphere among scientists is electric. They know that every second of observation will matter, that this is the chance of a lifetime. Never before has an interstellar object been predicted to collide with a planet in our solar system, let alone one so intimately studied. The Webb Telescope has pulled back the curtain, revealing not a static universe but one in flux, where alien objects can and do collide with the worlds we know. Mars is about to write a new chapter in its history, and through the instruments we have sent there, we will read it as it is written. The James Webb Space Telescope's confirmation that 3I Atlas is on a collision course with Mars has opened a floodgate of fresh ideas, predictions, and theoretical frameworks across multiple scientific fields. Every discipline connected to planetary science, astrophysics, and even long-term human exploration strategies now finds itself weaving this event into its ongoing questions. The uniqueness of this impending collision lies not only in the fact that an interstellar traveler is headed straight for a planet we have studied so closely, but also in the cascade of implications that ripple outward from this knowledge. The sheer precision of Webb's measurements has revealed not only the certainty of impact, but also nuances in the object's motion that earlier instruments could never have discerned. Scientists are analyzing the way the object is tumbling, the subtle flickers in its brightness that reveal its irregular shape, and the thermal signatures that betray its composition. Each layer of data paints a clearer picture. This is not just a rocky body with predictable density and structure. It carries a patchwork of ice, dust, and metal, shaped by environments far beyond our sun's gravitational dominion. Such a composition promises an impact with complex outcomes, where vaporization, chemical release, and fragmentation will intertwine to produce phenomena never before observed on a planetary scale within our reach. The location of the impact on Mars adds another element of fascination. Projections suggest the strike will likely occur near regions already surveyed by orbiters with high-resolution cameras. This means that before and after comparisons will be possible down to the finest details of topography. Scientists will be able to match features captured months before impact with those same regions transformed in the aftermath. It is rare in planetary science to witness a controlled experiment where a massive change occurs in a place so well documented. The juxtaposition of detailed before maps with the after crater and its ejecta field will provide a treasure trove of data for decades. This event also invites speculation about how such impacts have shaped the history of Mars itself. The planet's northern hemisphere, with its low-lying plains, is believed by many researchers to be the result of a colossal collision billions of years ago. By watching a smaller but still immense impact unfold in real time, scientists will refine their theories of how Mars acquired its unique surface features. They will see how molten material behaves under Martian gravity, how shock waves ripple through the crust, and how debris settles under the influence of thin air and constant winds. It will be like opening a window into the ancient past by watching the present. For astrobiology, the implications are equally profound. Mars has long been suspected of once harboring conditions suitable for microbial life, and evidence of organic molecules has already been detected in its soil and rocks. The arrival of 3I Atlas means the surface will be infused with elements and compounds from an entirely different star system. These alien materials might include exotic isotopes or complex molecules formed under conditions utterly foreign to the solar system. When mixed with Martian soil, they could create new chemical environments, miniature laboratories where interstellar chemistry meets planetary geology. For scientists investigating the origins of life, this presents an unparalleled chance to examine how biological precursors might form or interact when different cosmic lineages collide. The high velocity at which 3I Atlas will enter Mars's atmosphere also ensures a spectacular visual event. Mars's thin atmosphere will not protect the surface in the way Earth's does. Instead, the object will barrel through with minimal deceleration, generating a fireball that will outshine anything ever recorded on Mars before. Instruments on orbiters as well as telescopes on Earth will be watching for the sudden flare, the streak of plasma, and the brilliant detonation upon impact. The imagery alone promises to become iconic, a defining visual of planetary science in the 21st century. This event is also forcing scientists to rethink planetary impact probabilities. Until now, interstellar objects were considered statistical rarities, fleeting visitors that pass by unnoticed unless caught by chance observation. The fact that one has been captured not only entering the solar system, but also intersecting with a planet's orbit demands a reevaluation of frequency estimates. Perhaps interstellar objects are more common than previously believed, and their gravitational interactions with planets play a larger role in shaping planetary histories than we have accounted for. Mars, with its proximity and openness to observation, becomes a case study in the role of galactic debris in sculpting worlds. One cannot ignore the geological drama awaiting Mars. Upon impact, shockwaves will propagate through the crust, creating seismic activity that can be detected by instruments like NASA's InSight lander, if still operational at the time. Even if InSight is no longer collecting data, the principles it helped establish will be applied to model the seismic reverberations of the event. These shockwaves will not only provide data about the impact itself, but also reveal information about Mars's internal structure. Just as earthquakes allow geologists on Earth to study the layers of the planet, the impact of 3I Atlas could act as a hammer strike that resonates through Mars, offering clues about its mantle, crust thickness, and perhaps even the presence of subterranean ice. The dust cloud generated by the collision will also become a subject of intense study. Mars's atmosphere is already prone to dust storms that can grow to engulf the entire planet. The injection of a massive new plume of fine particles could trigger storm activity on a scale not seen in decades. Orbiters equipped to measure atmospheric dynamics will monitor how the dust disperses, how it interacts with prevailing winds, and whether it creates a temporary greenhouse effect by trapping heat near the surface. These changes will be closely tracked, not only to understand Martian climate, but also as a preview of what Earth might experience in the event of a similar strike here. An equally intriguing aspect is the possibility of ejecta escaping Mars's gravity. Depending on the size and speed of the impact, fragments of Martian rock mixed with interstellar material could be blasted into space. These fragments, some perhaps large enough to become meteoroids, might one day cross paths with Earth, delivering samples of the collision to our planet without any human intervention. If such material were to be found in the future, it would contain an extraordinary blend of Martian geology and interstellar chemistry, cosmic messengers carrying the record of this unique event. The broader astronomical community is abuzz with the theoretical implications as well. If interstellar objects are not just passers-by but participants in planetary impacts, they may play a role in distributing materials across the galaxy. Some speculate that life itself, or at least its building blocks, could be carried by such objects from one planetary system to another. The collision of 3I Atlas with Mars might be a small-scale reenactment of processes that have been occurring across the galaxy for billions of years, scattering organic precursors and fostering the emergence of life in unexpected places. The cultural impact of the confirmation is no less striking. Humanity has long looked to Mars as a destination, a stage for future colonization. To know that it is about to be struck by a massive interstellar traveler forces a reckoning with the hazards of settling other worlds. While engineers on Earth plan habitats, life support systems, and technologies to shield humans from radiation and cold, events like this highlight the unpredictability of cosmic hazards. Colonists on Mars, had they been there today, would face an existential threat beyond their control. The story of 3I Atlas is a reminder that colonization is not simply about technology and logistics, but about embracing the risks of living in an active and often violent cosmos. Meanwhile, artists, writers, and visionaries are already beginning to imagine what the event will look like. Paintings of a glowing streak slamming into Mars, novels imagining the perspective of a rover watching the sky ignite, films speculating on what interstellar debris might carry. All of these creative endeavors are flowing from the raw wonder of the confirmation. Just as Halley's Comet inspired generations of poets and painters, so too will the impact of 3I Atlas likely leave its mark on human culture, shaping the way we think about Mars and our place in the universe. International collaboration around the event has also reached new heights. Space agencies from around the world are pooling data, sharing orbital predictions, and aligning their spacecraft to maximize coverage. What was once the domain of separate programs has become a cooperative global enterprise, united by the opportunity to study a cosmic encounter that may not be repeated in our lifetimes. Instruments from NASA, ESA, JAXA, Roscosmos, and emerging space powers will all contribute pieces of the puzzle, weaving together a tapestry of observation that no single nation could achieve alone. From a philosophical standpoint, the confirmation brings into sharp focus humanity's relationship with the cosmos. For centuries, impacts were seen as random disasters that struck without warning, shaping planets and sometimes extinguishing life. Today, with the Webb Telescope, we see these events before they occur. We can predict them, prepare for them, and study them deliberately. This transformation marks a turning point in human history. We are no longer blind recipients of cosmic happenstance, but active observers capable of recognizing the dance of celestial bodies with precision. The countdown to impact will also be marked by a sense of anticipation unparalleled in astronomy. Unlike eclipses, which are predictable and frequent, or meteor showers, which arrive each year, the collision of an interstellar object with a planet in our own solar system is an event of staggering rarity. As the moment draws closer, telescopes across the globe will be pointed at Mars, and billions of people will know that they are about to witness a spectacle no human has ever seen. The world will watch together, connected not by borders or nations, but by the shared wonder of a cosmic event unfolding in real time. It is worth considering the scale of time that 3I Atlas represents. This object has likely traveled for millions of years across interstellar space, passing between stars, drifting silently through the galactic void. Its journey has ended not in obscurity, but in a fiery union with a neighboring planet under the watchful eyes of an intelligent species. The coincidence is staggering. Out of all the epochs of history, out of all the countless eons of cosmic time, this impact is happening precisely when humans possess the technology to observe it, understand it, and learn from it. That alignment of circumstance and capability is nothing short of extraordinary. Looking deeper into the future, the impact of 3I Atlas on Mars will leave a mark that outlasts humanity itself. Long after civilizations rise and fall on Earth, the crater will remain on the Martian surface, silently testifying to the day when a traveler from the stars slammed into the red planet. Future explorers, human or otherwise, may stand on its rim, sifting through the fused remnants of Martian and interstellar stone. They will see in it the record of a moment when the galaxy reached across the void and left its imprint on a world we dream of calling our second home. The Webb Telescope's role in all of this cannot be overstated. Built to peer into the faintest galaxies at the edge of the observable universe, it has also proven itself as a sentinel of the near cosmos. Its instruments, tuned for sensitivity beyond any predecessor, have not only unlocked the secrets of distant galaxies, but have turned their gaze inward, illuminating the drama of our solar system. The confirmation of 3I Atlas's trajectory is a testament to the telescope's versatility and to the foresight of those who built it. It reminds us that sometimes the most important discoveries are not in the farthest reaches of space, but in the cosmic neighborhood we inhabit. The collision course of 3I Atlas with Mars thus stands as a convergence of science, culture, philosophy, and imagination. It is at once a moment of danger, of opportunity, of revelation, and of inspiration. Mars will change, the universe will remind us of its power, and humanity will watch, learn, and remember. For all the centuries that follow, the story of 3I Atlas and Mars will be told as the time when a starborn traveler met a world that humans had long dreamed of touching, and we were there to see it. The impending impact of 3I Atlas with Mars is not just an astronomical event, it is also a turning point in the way humanity organizes its scientific priorities and intellectual curiosity. Now that the James Webb Space Telescope has confirmed the trajectory, researchers are asking questions that extend well beyond planetary geology or orbital dynamics. They are beginning to think about how this collision fits into the broader story of the solar system's evolution, the interconnectedness of interstellar matter, and the profound role of cosmic chance in shaping planetary histories. One of the most overlooked aspects of this event is its educational value. Across the globe, classrooms are preparing to integrate real-time data from Mars into their curricula. Students will not just read about impacts in textbooks. They will follow along as scientists post fresh images, seismic readings, and atmospheric changes from orbiters and rovers. For the first time, young learners will witness a large-scale cosmic collision unfold in real time, building a visceral understanding of planetary processes that no simulation could equal. This experience is expected to inspire a new generation of planetary scientists, astrophysicists, and engineers who will carry forward the lessons of 3I Atlas into future decades. The economic and industrial aspects of the confirmation are also noteworthy. Space agencies and private companies alike are suddenly faced with a wealth of opportunities to test technologies. Companies focused on resource extraction, for example, are interested in how the impact may expose subsurface materials on Mars. A strike of this magnitude could fracture bedrock, uncover hidden mineral veins, or melt pockets of ice that were previously buried. If humanity one day seeks to mine Martian resources, the natural excavation created by 3I Atlas may serve as an early case study in how impacts shape access to buried reserves. The physics of the collision itself presents a host of puzzles that Webb's data will help solve. Unlike typical asteroids whose origins lie within the solar system, interstellar objects move at unusually high velocities. The speed of 3I Atlas relative to Mars ensures that the impact energy will be far greater than a comparably sized local asteroid. Scientists are modeling how such high-velocity collisions differ from ordinary impacts. Will the crater be shallower or deeper? Will the shockwave fracture the crust more violently? Will exotic materials vaporize in ways that alter the chemistry of the atmosphere for weeks or months? Each of these questions carries implications for understanding not only Mars, but also collisions that may have happened long ago on Earth and other planets. There is also the matter of magnetic fields. Mars has no global magnetic shield, only remnants of localized magnetism preserved in certain regions of its crust. When 3I Atlas slams into the planet, it will create a burst of plasma and electromagnetic activity. Researchers are eager to see whether this triggers temporary magnetic disturbances in the Martian environment, phenomena that orbiting spacecraft can detect and measure. These observations may reveal how impacts influence the interaction between solar wind and unprotected planetary surfaces, a topic directly relevant to the habitability of planets without global magnetic shields. The biological dimension of the impact, though speculative, is captivating. Some scientists propose that interstellar objects like 3I Atlas may act as couriers of complex organic molecules. If any survive the descent and embed themselves in the Martian crust, they could provide entirely new compounds for researchers to analyze. Even if life does not emerge from such chemistry, the delivery of complex organics could catalyze new reactions in Martian soil, creating a more chemically diverse environment than before. Such diversity could be critical for astrobiology studies, offering insight into how life might arise under different cosmic influences. From the perspective of planetary engineering, the event becomes a case study in terraforming by accident. The dust injected into the Martian atmosphere could temporarily warm or cool the planet, depending on particle size and distribution. If cooling occurs, it might trigger the condensation of carbon dioxide at the poles, thickening the seasonal ice caps. If warming occurs, it could release subsurface ice as vapor, thickening the atmosphere slightly. Neither change would be permanent, but both would illustrate how sudden infusions of material can alter the climate of a planet, even if briefly. For those who dream of terraforming Mars, 3I Atlas provides a natural experiment on a miniature scale. The role of artificial intelligence in analyzing the flood of data cannot be ignored either. Webb's confirmation has already spurred agencies to prepare AI-driven pipelines capable of processing terabytes of information from orbiters and rovers. Machine learning models will track dust dispersal, seismic vibrations, and atmospheric chemistry in real time, identifying patterns invisible to human analysts. This event will likely become one of the first major astronomical occurrences where AI plays a central role in the immediate interpretation of data, setting a precedent for how science will be conducted in the future. Another overlooked dimension lies in the realm of interplanetary diplomacy. The confirmation of 3I Atlas has galvanized cooperation not only between scientific institutions but also between governments. Nations with rival space programs are finding common ground in the shared goal of documenting the event. Joint missions, data sharing agreements, and collaborative observation campaigns are being drafted at unprecedented speed. In a world often divided by politics, the collision with Mars serves as a reminder that some cosmic phenomena transcend terrestrial divisions. The sky, after all, belongs to everyone. The psychological dimension of the collision also deserves reflection. Humans have always seen Mars as a quiet, barren world waiting to be explored. The knowledge that it will soon be violently struck by a massive interstellar traveler changes that perception. It reminds us that planets are not static backdrops, but active participants in the cosmic drama. Mars is no longer just a passive goal for exploration, but a world whose fate can be abruptly rewritten by forces from beyond. This shift in perception may affect how people emotionally connect with Mars, deepening both the sense of awe and the recognition of its vulnerability. For planetary defense strategists, Mars now serves as a rehearsal ground. The event forces experts to consider how Earth would respond under similar circumstances. Unlike Mars, Earth has billions of lives and a biosphere to protect. By studying how 3I Atlas interacts with the Martian surface, atmosphere, and orbit, scientists will refine the models they use to plan for potential Earthbound threats. In a sense, Mars becomes humanity's proxy shield, taking the brunt of an interstellar collision and allowing us to watch and learn without suffering the consequences ourselves. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I Atlas colliding with Mars? We want to hear from you. Thank you for watching and see you next time.